Hello guys, welcome to JLC. My name is Srinivas Dande. I am the mentor for the system design course and welcome to all. So in this session, we will see how system design is important in the real world application and how companies are using this and how you will use this in the company. And when you attend interviews, when you're attending top tech companies or any product based companies, so mostly nowadays, two major things what companies are checking. Number one, system design. Number two, data structures and algorithms. There's a problem solving. So how good you are in solving problems and how you are able to design scalable systems, scalable, maintainable systems, a large scale systems, how to build, right? So this is about system design. So the course name I designed as Master System Design, Fundamentals to Modern Practices. So consider you do have zero knowledge on this to you can see current trends, how industry is following. And thank you all of you. I'm seeing most of my older students who joined with me long back and who got jobs settled across the globe. I'm proudly say that my students working across the globe, mostly 90% in India only, but 10% of the students are there in different countries like US, UK, Canada, Australia, Ireland, various countries, right? Yeah, I think a student from Prasad from he's 2011 joined at JLC, now in USA, still referring my content. Thank you, Prasad. And many are there. I think from US also many students joined. This time slot 6:30 p.m. is taken especially to make the time comfortable with students in other places, other countries, right? So, right, let's start with. There are two aspects in learning system design. So, I'll ask you a question: why you want to learn system design now? Why you want to learn system design? Why you want to learn system design? Lakshmi Kant is telling you want to become an architect. Means, so when you want to go to interview, definitely there is system design interview, right? You will have a system design interview, you have to crack it. Or maybe in your company, to understand your application architectures and to make it deeper, to understand, yeah, robust systems or scalable systems, to build good software. Then the good software, we will use a term like how to design a scalable, maintainable, high performance systems. Scalable, maintainable, and high performance systems. That maybe you may get a chance to design an application in your current company, or if you are planning to change the company, maybe you have to face a system design interview. So what will be expected in system design interview? So all tech companies I'm talking, I'm not talking about service based companies like TCS or Infosys. So I'm telling top tech companies like Google, Facebook, Amazon, Microsoft, Apple, Netflix, right? Or many other product-based companies. So these are all companies for a senior level people. Definitely there is one interview called system design interview, right? System design interview. Now, so the goal of this course, there are two goals for this. There are two goals for this. Goal number one, crack, how to crack system design interview. So if you have good experience, maybe I think, so I'm seeing the audience who attended my demo. When I see your statuses, when you applied for this course, most of the students, 80% of the students are from 10 years to 20 years. 10 to 20 years, I'm seeing 10 to 20 years, 80% of students are there who are attending this session. And 20 plus also 15% of the students who applied for this course, 20 plus are there. And below 10, very less I have seen, very 5% of the students are having below 5 years of experience. So, right? So, any of you wants to change a job, because all of you are at senior level. So, if you want to change a job, then definitely you have to face system design interview, right? Goal number one. Goal number two. So maybe in your current company, or if you change a job to a new company, if you get a requirement to design the systems, design system, you have to design a system. Maybe if you are a senior member, maybe a tech lead or architect, associate architect, or solution architect, depending on different roles. Maybe you have to get a requirement to build systems. So my course is targeted at two. In your current company, if you have a requirement to build scalable, maintainable, high performance systems, how to do that? Like you see, there are many real world use cases. See the YouTube. If you want to build an application like YouTube, if you want to build a video streaming platform like a YouTube or a Netflix, how to build it? What are the key constraints you have to consider? Or if you want to build a social media platform like a Facebook or Insta or a Twitter, what is the things required? Or if you want to build applications like Uber, there are different aspects, right? If you go to Uber, you don't have much work videos, not there. But the real-time tracking is the key criteria. But all are large scale systems. And if you go to, for example, food delivery, Zomato or Swiggy, right? How to build those? Real-time ordering, real-time data processing is required. Whenever you order, even nowadays, order is coming on the way, 5 minutes, 10 minutes, they're showing all that. That's real-time data tracking, right? Or online e-commerce applications like Amazon, Flipkart, like these are the largest applications in the globe. So how to build these applications, right? So the end of this course, you will be learning how to design this large scale systems. Second, if you go to interview, if there is system design interview, how to crack it. So first, let me to tell you about system design interview. Suppose you are trying for an architect job. You want to try an architect or maybe a tech lead, even an individual contributor for a senior role, some principal engineer, something like that, some companies with a 10 plus, 15 plus years of experience also. So there is system design interview. So what will be expected in the system design interview? System design interview is not like other interviews. For example, if you are facing a coding interview, they may give you some problem. You have to find a solution for that. Maybe you can find a solution using graph algorithm or a tree algorithm, or maybe using dynamic programming, or using some other array technique, sliding window technique, or some other technique you can use to solve the problem. Or if it is a technical round, for a given question, you have to answer it. For example, take it Java related. Suppose if I ask you what is how to implement the transactions in Spring framework, or how to implement transactions in Hibernate framework, or how to implement transactions in Spring Boot. So this kind of questions, there is a straight answer. There is only one right answer. Am I right? Any technical questions, there is a one right answer. You have to tell this is the question, this is the answer. But system design interviews are not like that. System design interview, a question is asked in system design interview, there is no answer, or there is no straight away answer. It is a kind of long discussion. They want to find your in-depth knowledge on various concepts, how to build a distributed systems. In a distributed systems, what are the key components we have to write? What are the things like how you will maintain the resilience, how you will maintain high availability, how you will maintain persistence, how you will maintain consistency, right? So how you understand this? These are the words like very smaller. For example, you see resilience, high availability, and maybe consistency. This mostly similar, but there are key differences internally. So these all you have to understand it deeper. Means in system design interview, for a given question, there is no answer. You need to say answer for that. What they expect is you tell all the possibilities. Means you should know all the possibilities. Yeah, if this is a problem, this may be a solution, this may be a solution, this may be a solution. Now from those, depending on the context, how to select the corresponding, right? Exactly, Adnish. To understand an overall system, participants, and that's all about system design. All right. So these are the two goals of my course. So let's start with the individual modules of this. Right. So all of you know, as you have lots of experience and you know the SDLC life cycle, right? So it starts with gather the requirements, analyze, then go for a design. Once the design is completed, go for a coding, then testing, then deployment, then maintenance. And they are the common phases of any SDLC. So I think most of you have started your career in the coding. Am I right? Most of you have started your career with coding. So like I'm seeing most of you are my old students who studied with me at my old different branches at Matikere, BTM, Marathalli, all various branches, right? So you all got a job as Java developer long back. So then you grown, now you are at a senior position, right? So this course is at design. So we are now design. So we are talking about design. So how a design, you can implement a design in two levels in general. high level design and low level design. So first start with the high level design. In high level design, you identify various modules or components and how these components can interact. And for these components, what are all additional facilities you have to provide to make it more secure, to make it larger scale, to make it high available, to make it consistent, like caching, etc., various components you can introduce to the main. So, and then once the high level design is done, you can start with the low level design. I'm assuming maybe 90% of you guys are already comfortable with low level design. These are the various modules I'm going to explore with high level design. In high level design, I'll explore each module. First, let's see the list of modules. In the high level design, we're going to system design fundamentals, requirements, and constraint analysis. These 1 and 2 are simple modules, actually. Very less time it takes. But important modules are 3, most important. When you go to interview, when you attend system design interview, module 3 is most important. 4, 5, 6, and 7, 8. 8 is the most important, guys. Directly, what kind of questions they'll ask you, I designed here. This, if I say, what are the super important? This, and 3, 6. 3, 6, 8, 9. Remaining, it doesn't mean remaining are not important. These are very important. Why I'm telling very important? Whatever I'm going to cover you here, mostly you will get similar questions in the system design interview. Mostly same or similar, or at least I say 90% of the questions you face in the system design interview will be coming from this. You will understand how it comes. After seeing the individual syllabus, you will really understand whether really these will be coming. 90% of the questions you face, you will see from this. Right. So, module 1, in this mostly what is system design, all this basics and high level, low level. What are the key things about, key principles about system design, like scalability, reliability, maintenance, performance, security, etc., and top-down approach or bottom-up. Some cases you will choose top-down. Some cases you will choose bottom-up. I think you know this top-down, bottom-up. You hear. Can you tell me? Can you tell any of the real-world applications what we are using in our daily life? Anyone using bottom-up? Anyone using top-down? For example, you take the YouTube. Take YouTube, guys. YouTube built based on top down or bottom up? YouTube built based on top down or bottom up? Very good. Very good. You're right. Kaushal, Rupesh, Ramprasad, Munna. This is a bottom up because when YouTube launched, this many features not there, this many functionalities not there, this many number of user base not there, this much scalable system it was not. So they came with an idea, they started, then incrementally they built, user base increasing, then they started thinking about how to scale. Scaling is one, and whenever user base increasing, their video storage also, right? They have lots of video storage. Video storage, they have to increase. So the build features, there's a bottom up. So when to go for top down, like that we will discuss. That's anyway, we'll discuss on the way. This is a module 1, right? Module 2, This is all about requirement collection and what are the constraints you have to analyze, understanding requirements. We'll take some real-time use cases. We'll start designing the application like. So in our syllabus, I'll come back to this again. Let's see this. Yes. So in our course, we are going to build these eight different categories of applications, guys. So we will see the complete high-level design of either YouTube or Netflix, your choice, you can pick, or social media platforms like Insta or Facebook, e-commerce like Amazon or Flipkart, financial like PhonePe you want, messaging like WhatsApp or Telegram, food delivery, Zomato, Swiggy, transport, Uber or Ola, ticket platforms like MyShow or Just Tickets. Right? Yeah. So these features are different. Am I right? For example, these are the eight categories I picked. These are the most eight different popular categories. If you know the each and every point how to design these kind of large scale systems, you can easily crack the system design interview. Even in your company, if you get a chance, you can really build a system, something like this. Okay? Right? Aditya is asking about, can you give an example which is built on top-down approach? Top-down approach, you can see mostly the companies which are coming up later phases. For example, you take the Google Pay. Google Pay is not the first financial payment wallet, right? So they came with the full clarity. So by the time when they started designing the say Google Pay, and they have already a lot of other applications available. So they have a full clarity on the complete functionalities, what to do, how to scale everything. Then they started with top-down approach. That you can say as a top-down. Yes, Munna. That is a different. For example, you take Instagram. Instagram initially built as monolithic only. Instagram initially built as monolithic only. So whenever their user base increasing and the images and those all increasing, then they want a real time feeding, messaging. Then they broken down into various pieces, microservices. So Instagram initially built with uh, monolithic. They migrated depending on the demand to microservices. Now, if you want to build, you are easy. But when Instagram built, the time microservice architecture was not good. Even Netflix initially started as monolithic and later they broken down. Even Amazon e-commerce platform also initially uh, built as monolithic. They migrated with microservices, right? That will come back. So these are the applications we're going to see. These all will build it. Now back to the model number 2. So in model number 2, we will take those scenarios. So we will understand requirements of any application and how to, in that, what are the functional and non-functional. So tell me, for example, what are the functional requirements? For example, you take the food delivery Zomato. In Zomato, what are the functional requirements, guys? In Zomato, what are the functional requirements you have? Authentication, order processing, very good. Payment processing, order, payments. One location, one guy tracking, Dharmendra, yes, one more guy has answered. Real-time tracking, right? Real-time location tracking, yes, that is important. Real-time location tracking. Real-time location tracking. Those are the functional requirements. Yeah, anyway, recommendation engine. Yes, preferences. Lakshminath, you're right. That's how they're going to use the machine learning algorithms. They're using machine learning algorithms and building the recommendation systems. Almost, almost nowadays, every platform, whatever I told, 8 categories, everybody having, not only those, anybody can show recommendation systems based on the machine learning algorithms. Like if you go to Netflix, when you are watching one movie, they'll show that similar to this. Or if you go to Zomato, if you buy something, they'll show similar to this. If you go to Amazon, if you buy something, they'll show similar to this. Right? YouTube, if you see one video, if you're seeing one video, they'll show similar to this, some other videos. The recommendation engine almost required, but it is generally a part of, mostly we have wonderful machine learning algorithms to build recommendation engines. Right? So those, and what about these are all what you told are the functional requirements. What are the non-functional requirements on this? What are the non-functional, guys? Very good. Very good. Performance, scalability, availability. Very good. All time available. Right? Consistency. See, logging, security, you can logging security. Logging is maybe you can call it as, but security is a, Adnesh, security is a functional requirement because authentication is a functional requirement. Performance, high availability, right? Scalability. These are all non-functional requirements. So you have to understand, for my system, what are the functional requirements I need? What are the non-functional requirements I need? Once that is done, you can think about constraints in system design. What constraints you have? So what's the time you have? Time constraints or cost. So if you have maybe any limitation, so in that how to prioritize the constraints, all that you need to understand. And very importantly, trade-offs. This is most important term in the system design interview. Trade-offs is most important term you need to learn. So I'll explore this for some time. Then preparing clear documentation, right? Clear documentation and all that, metrics, validation, all that. This is the module 2. Then go to the, I marked it as important, means important, very, very important. See, module number 3, guys, super important. It's a very, 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 very important. You should have clear understanding of all this. Load balancers, caching, API gateways, SQL versus NoSQL, when to choose, data partitioning. Partitioning is most important. Indexing, proxies, some network essentials, DNS, CDN, right? Redundancy and replication, CAP theorem. I kept here under CAP theorem as an important because, but this I will explore in a further sessions. Like in a distributed systems module, I'll explore about CAP theorem and advanced CAP theorem is there. This all I'll explore in a. So these are the continuations. Still we have some more around consistent hashing, long polling, WebSockets, Bloom filters, quorum, leader and follower. This heartbeat messaging, leader and follower for the distributed systems only. If it is a distributed system, definitely many of this you need. These are module 3 core concepts. You should have a clear understanding of each one. Yes, Nehal. Module 3, yeah, SSE, server-side events also. Maybe I missed it, Girish. Correct, you are right. Servers and events also one is there. There are some more I didn't get a chance to add. Many are there actually. right? So, and I have these I will cover in a vertical way, guys. Sorry, I'll cover this in a horizontal way. Horizontal way means in the appropriate module, I'll cover it. Okay? Yes. Right? Solid principles session will come in a low level design. That we will see in a low level design. Okay? So these are the various, still there are missing points. And if I miss anything on them, we will add it. No worries. We'll add those. There's a model 3, most important. Next model 4. I didn't mention as important. If you see my previous modules, guys, for example, go back. Model 3, I given as important, super important. Means this is where you need to stress, and interview questions will be asked here only, exactly here only, right? This is also important, but maybe not in this. I think some you know already. I think most of you have studied microservices in my microservice sessions only, right? So you know monolithic, you know microservices, right? And most of you guys have attended my AWS sessions also. In AWS, I told you about a serverless architecture, right? Serverless Lambda, right? So that's what I in interview required, but various kind of architectures we will discuss here. Now, which is important nowadays, the module 4, the distributed systems, most important. So nowadays, whatever systems you build, if it is a small application, nothing to worry all this. If it is a larger applications you build, definitely it is a distributed system. So what are the important challenges you face in distributed systems, right? How you follow the consistency, how you think about latency, fault tolerance, resilience, and high availability. These are all important to apply here. Then we'll talk about distributed transactions, how you do the distributed transactions, distributed databases, distributed caching, distributed system patterns. There are some design patterns which can be used with any distributed systems. And communication, how communication happens between various systems in a distributed model. This is also most important. Next, microservices. I think as you are working already in microservices, but still I'll explore about microservice architecture. And most importantly here, we'll talk about, this is the most important file. If already you don't know microservices, fine, we'll understand only here. I know, I think most of you have done my microservice courses also. So here, why I'm telling this as most important is, this all mostly you know, but anyway, we'll make it more clear theoretically and what kind of questions we can expect on this. Important is system microservice design patterns, guys. The next is important. Microservice design patterns. Each design pattern will understand thoroughly. What are the decomposition patterns, integration patterns, data management patterns, resilience patterns, right? In this resilience related, we have circuit breaker and bulkhead isolation. Saga pattern, most important. Definitely they'll ask you, if you want to perform distributed transactions, you need the Saga pattern, right? So these are all design patterns we'll understand. So you will get the questions on these design patterns. So you have to thorough with this design patterns. So once it is done, we'll go to the module 7, cloud native architecture and patterns. This is also important. The cloud native is only difference. Previous module 6 is microservice architecture, how to build that. What are the patterns we're going to study. Now, the microservices, either you can run in on-premise or maybe in the cloud. So when you're running in the cloud, nowadays, what is the trend? What is the trend, guys? Every applications are using microservices, number one. Number two, If microservices are there, then people are using Docker and Kubernetes. You have to run your microservice in the Docker container, and Docker containers has to be orchestrated by the Kubernetes runtime, a Kubernetes cluster. And this setup is you can place in a cloud or maybe serverless architecture. So mostly on the cloud native architectures can be a microservice architecture or serverless architecture. And another common trend nowadays is the DevOps. These are for a CI/CD pipeline, continuous integration. That's all about module 7. So I didn't mention here as important, if you understand, guys. I didn't say corner, if you see, I didn't keep as important because in system design interview, if you go to Google, you go to Facebook, go to Amazon, go to you will not get these questions, right? These they won't ask. They may ask you these questions, maybe microservice related questions or Docker related questions, Kubernetes questions, DevOps questions. They may ask in technical round, in other rounds, but in system design, you may not get a question. This we are doing in a different purpose. So that's and another most important, guys, trade-offs. You should understand each difference. Consistency, it can be a strong consistency or eventual consistency. Strong consistency, you can also call, I think maybe here as a transactional consistency. If you are using asset properties is a transactional consistency or a strong consistency. If you go to base properties, it may be eventual consistency. So for the system you are designing now, you need a consistency. Okay, first we have to understand what is consistency. Okay, now the consistency can be implemented as a strong or transactional consistency or eventual consistency. Now, the system you are designing, what is required? What is required? Whether to use, in some use cases, you need strong consistency. In some use cases, you need eventual consistency. That is where the interview person will check how strong you are in the concept. You have to suggest, yes, boss, this is the consistency in this kind of applications. Suppose if they ask you to build an applications like Uber, you are building a Uber. So there, what we need? What kind of consistency has to be implemented? Like latency versus throughput, ACID-based properties, read through, write through caches, batch processing and stream processing, load balancers, API. These are the trade-offs, very, very important. You will get this. I have written more because of slides are increasing. I reduced. Actually, I have more than 50 plus things I identified most commonly asking. I just given around something here. I don't know. I didn't remember it. See, proxy versus reverse proxy, API gateway, reverse proxy, SQL, no SQL, server side caching, client side caching. Every small, big. Maybe some of you know, guys. Some of you know already. Maybe REST versus RPC, you might land already. Token bucket versus leaky bucket. Maybe you don't know this. So maybe as you have lots of experience, some of you already you know, but and more clearly we'll discuss those plus many new things. All right, stateful and stateless architectures. Yeah, even gRPC also. Yeah, like if I miss anything, maybe you can guide me. I'll add those, right? Read heavy versus write heavy systems, vertical scaling, horizontal, this, I think. Monolithic microservices, mostly, synchronous, optimistic locking versus pessimistic locking. Maybe if you are my older students in Hibernate, long back only we discussed sharding versus partitioning. So you should understand sharding, partitioning, when to choose this. These two are most important topics These are there in the module 3 components. There we'll study what is sharding and partitioning. So now it's a time to choose depending on the applications, right? Event driven, request driven, pull systems versus push systems, batch processing versus real-time data processing, data replication or data backup. Which one to choose? Consistency, availability, or partition tolerance? Which one to choose? Graceful degradation or fail fast? So you tell me generally what you do, graceful degradation or fail fast? We need the graceful degradation or graceful shutdown. Means some problem happened as a part of system, guys. Do you want to collapse system immediately? Fast fail? No. So it has to gracefully degrade. Maybe by the time your backups, other rest, when to go for rest, when to go for GraphQL. Idempotent based on security, idempotent and data sharding versus clustering, in-memory databases versus disk-based, stateless microservices, stateful, and high availability versus fault tolerance, replication versus partitioning. I covered most, still if anything missing, we'll add it on the way. So after all understanding, then we'll go for building or designing applications. So we will pick this and we will do the complete design of. So after understanding all the concepts, then we'll start building this, guys. We'll say we'll pick either Netflix or one idea we'll take Instagram, Amazon, PhonePe, WhatsApp, Zomato, Uber, BookMyShow. These if you want to build. So when you attend system design interview, they may ask you, boss, okay, you design the WhatsApp. Where you will start? What you have to do? What you have to show in the interview? Right? That's we'll do it. So these are the 9 modules, guys, we have in a high level design. Okay. Module 9. We will see the design of these applications, what you're seeing on the screen. We'll pick one from video streaming platform, one from social media, one from e-commerce, one from financial, one from messaging, one from food delivery, one from transport, one from ticketing system. 8 applications we'll build. We'll design, not build, sorry. We'll design this 8 applications as a part of our syllabus. Before that, we will understand all the important trade-offs. Trade-offs module is 8. I told us very, very important. You will get these questions as it is in the interviews. And still we'll add other trade-offs coming up. Yeah, parking slot also on. Maybe we can do that. Parking slot is something similar to, yeah, I have taken Santosh. Booking also kind of same idea, right? Gopal, those are there in a low-level design. Yes, we have those low-level design we have. I'll show you that next, right? So trade-offs most important, guys. I am telling in the sense, in a system design interview, if you have a 10 plus years of experience or 5 plus years of experience, whatever, even you have 20 plus years of experience, when you are hitting a top product-based companies, either FANG companies, MANG companies, or even other top tech product-based companies, there will be a system design interview. In the system design interview, 6 design patterns important, distributed systems questions you will get, core components, right? Next. And see the 9, these are the ideas we will see. Video streaming, social media, e-commerce, financial, messaging, food delivery, transport, ticketing, right? So these are the concepts we need when you design a problems. The model number 9, if you see system design interview problems. So if you're designing some application, we have to pick catching. Suppose, see the CDN. For a food delivery app, whether CDN is required, you tell me these real-time questions, guys. You can answer, I think. Some of you are having. You tell me, for a food delivery app, CDN is required. No, guys. CDN is majorly required for a global, right? For Netflix, for a Netflix, Netflix, Netflix needs the video streaming platform. Netflix needs the video streaming infrastructure. Video streaming infrastructure required. CDN required. What about recommendation systems? Yes, recommendation systems required. Data storage, yes. Caching, yes. Performance, yes. Scalability, yes. And real-time data handling. Real-time data handling required for Netflix. Mostly no. Mostly no. Right? Recommendation systems, recommendation, yes. And okay. Now go to, now I'll pick the application. Take the Uber, guys. Uber. For Uber, video streaming infrastructure not required. CDN, CDN not required. CDN not required. Nothing to catch, guys. No CDN in the Uber. Why? When you standing in Bangalore someplace, for you, when you search, right, it will show something nearest to you. Either you book auto or a cab, whatever, nearest only it has to see. Nothing to see catching. No CDN. And recommendation systems for Uber. Mostly no. Mostly no, yes. Data storage, yes, basic data is required, but it is not too heavy like social media, too heavy like Insta, YouTube, right? Performance optimization, yes, required. Scalability, yes, required. And for this, what is important, guys? Real-time tracking is important for Uber. Real-time location tracking is important. Real-time location tracking is important. What about the push notifications, guys? Push notifications or the real-time messaging, both are same. Push notifications are real-time messaging, yes, required. Payment integration anywhere required. Payment integration is required, yes. And scalability, load balancing is required, right? Yes. I think some are repeated, I think. Okay. Right. Like this, we will design various applications so that we'll have a complete knowledge. Huh? Search and indexing. For example, you go to e-commerce applications, Rupesh. E-commerce applications, you go to Amazon, you are searching for products. So you have thousands of products in Amazon. So this, whenever you search, these products are internally indexed, right? Whenever you search, it has to search one product among thousands of products. So searching should be faster only when you done indexing on that. Searching is faster only when you do indexing on that. Question from Adnesh, simple question. Yeah, do we design the system based on the requirements, or first we design the system based on the domain and fit to the requirements? Adnesh, good question. See how the system design interviews happening nowadays. If you go to, for example, Amazon, if you go to Google, or if you go to some company, some top tech company, not only this Fang Mang, any tech companies at least who are paying very good salaries, they will ask you that, boss, I want to build application like YouTube. Can you design? YouTube is doing super good in the globe, right? So I am getting a lot of funds now. I have investors ready. I want to build an application competitor for YouTube. Can you build YouTube system now? Or I want to build e-commerce platform like Amazon. Can you build now? Show me how you build it. Or I want to build Ola app. Can you build now? Maybe better than Ola. Tell me how you can build. That's how you should learn it. If you know how you're building this large systems, then exactly, Dinesh. So if you know in and outs of these large systems, your small applications you can very easily build, right? You have a clarity on how to build and how to design the systems like this, then game over, right? That's what you can, small applications, small companies, nothing to worry on that. Then you know you fit into any organization, any top tech company, you can hit the interviews. Okay, guys, any questions I missed? Yeah, Ram Prasad, uh, to build an app, how to pick technologies like, that's what we will learn. We will learn, Ram Prasad. That is a part of my course. Very good question, Ram Prasad. So how to pick the technology stacks? If you are an architect, so if you are an architect, guys, suppose we decided, suppose we are getting a funds and we are getting a funds, maybe we decided to build an application like Zomato, or we decided to build an application like Voila. Now, once the design, as a part of a design, you understand your functionalities, functional requirements, non-functional requirements, and these all like whatever we need to add for scalability, etc., all. Then what technology stack to implement? Next question. We have to answer that. And then once technology stack is ready, where to deploy this? You want to go for a cloud? You are go for on-premises or hybrid model? Some of the systems you want to build on the, that's all decision making. Yes, that also technology stack, choosing technology stack, right? And then this all we'll discuss as a part of this. Yeah, Yuvraj, database design also there, and I kept that in a low level design. So is this high level design clear, guys? High level design clear? Yes, Gopal. Yes, the goal of this is you can crack technical architect interviews, any technical interview, right? Okay, done. So next come to the low level, guys. Low level, we have this model number one, just low level design, this basics. Okay, number two, design principles, most important. Number three, design patterns. Number four, UML diagrams. Number five, number six, database modeling I given here, guys. Concurrency, threading and algorithms. Okay, testing, validation, code quality, code review, the module 8 is, and 9 is the real world use cases. So whatever high level design we are done, for those, we will do the low level design. For example, we have done a high level design in the first module, in the first section, high level design we done for a Netflix. Now for that Netflix high level design, we'll come for a low level design, I will do that. Okay, module wise breakup of this. I didn't kept important because it comes with the basic things about low level, this, that story. Two, guys, very important. Design principles. Yes. Solid principles. Solid. No, data structures, algorithms will not be covered here, Pankaj. That will be a separate course. I'll tell you about that. No need to know, Adnesh, data structures and algorithms. No need to know data structure algorithms. But remember, if you are hitting for a product-based companies, tech interviews, you should master the DSC also. I'll tell you about that at the end, but this is exclusively system design in-depth interview, which is after learning this, you can aim at any top tech companies. Even you can, I'm telling you can go and sit in the Google also. Yes. So module 2, I'm telling, this is the low level design module 2, guys. Low level design module 2, most important, covers the all important design principles, like solid principles, all will study. Then these all others also. RY is actually D missing, guys. Is a dry, DRY, dry principle it is, D missing in this. Dry, kiss, agni, composition, how to choose. Composition you want to choose, and inheritance you want to choose, right? These all we'll see. Design principles, more deeper into design principles. You will get more questions on this. That's what I kept this as important module. Model 3, design patterns, guys. Yes, here are the design patterns, right? Yes. Creational design patterns. Yeah, Gopal, this is the answer for your question. Creational patterns like singleton, factory, abstract, builder, prototype. Structural patterns like adapter, bridge, composite, decorator, facade, flyweight, proxy. Behavioral pattern, chain of responsibilities, command, iterator, mediate, observer, state, strategy, visitor, right? These are all patterns will be in this model 3. I given as most important because yes, questions will be asked. Even required for you really in your company design, you need it. Next, UML diagrams. Yes, we will learn how to draw, we'll understand various, we'll take a use case and we'll design that. Low level design we'll do. In that, we'll draw the various use cases. Complete scenario, we'll do it. We'll use some tools. We'll use the tools like either Lucido chart or maybe Drivo. Lucido chart, I feel Lucido chart, Drivo, second option is there, Figma is there. We'll pick one which is easy and we'll use that. Next is important, detailed design. We'll understand detailed design of each application. And yeah, somebody asked about database design also there. Yes, guys, we'll talk about database design. We'll talk about ER diagrams, ER modeling. I'll explain you the normalization. All the normalization levels I'll explain. First normalization, second normalization, all the normalizations I'll explain clearly and you master it. Denormalization, indexing and how you do query optimization, all that. Pankaj question, will you create any demo app at the end? Building an app, we won't go for any coding. Just I'll show you the code snippets, guys. For example, if you take an application like suppose movie ticketing or something or whatever, we'll see the database design of that. Sample database, we'll draw ER diagrams, but we won't do any code. Like here, for example, for a ticketing system or e-commerce system, whatever you pick there, for that, how we will do the detailed design. I'll show you all the diagrams, but you won't see any code, full-fledged code. It's not a development related. So it is all about design related things. Okay, database modeling, all normalization, ER diagrams will learn in depth here, including indexing, query optimization, how to do all the techniques we'll learn on this. 7 is most important, concurrency, threading, and algorithms. What concurrency algorithms you can use? What kind of, because this also makes a key role in the performance, guys. Concurrency also makes a key role in the performance of the application. So how you do this, what kind of patterns you can use for concurrency patterns, you say, concurrency algorithms, you say, right? We'll talk about that here in this model number 7. That's what I given as a most important. Yes, questions you may expect on this. This is just I'll give you overall idea about if they ask a testing related. You don't expect any code. I'll going to give you code samples. I may give you these are tools. What is what to do? Tools, how to use, basics, right? And this is 8. Now is the by end of this we will have a low level design of these applications also. Okay. That's all about all the modules, guys. So I hope you understand all the modules and explanation of high level and low level designs. All right. Now, we have that. Amar, we will understand. We have a topics here. So maybe I'm not going to the particular place where we need, say, in core components when you talk here, see. So here we have database related, right? I just given as SQL versus NoSQL. Also, we will understand here about time series data, what are SQL databases, for SQL database related performance, how to handle, no SQL related or time series data is there or object data is there, like we'll understand those, all right? So this is all about all the modules, guys. Now, yes. So coming to the duration, timings and price, this regularly classes will be started on every Saturday and Sunday at 6:30 p.m. IST, and for my students who are in other countries, if you are EST zone, it is 8 a.m. early morning wake up, you can get ready for the class. There are some students at PDT time zone also. I think PDT means now 6:30, PDT they have I think 5 o'clock early morning. It may be a tough. No, no, no. This is Navneet. It is not like that. For Indian students, 6:30 a.m. Sorry, 6:30 p.m. IST. For Indian students, this is the timings. Who are at EST time zone in US other countries, for them 8 a.m. Is a 2.5 hour session, Navneet. Is a 2.5 hours every Saturday. Saturday 2.5 hours. Sunday 2.5 hours. Maybe if any topic extra, I'll take up to 3 hours. So minimum 3.5 hours it will take. 5 hours per week. You have to listen my classes. You have to listen my classes Saturday 2.5 to 3 hours. You make it as 2.5 to 3 hours, 2.5 to 3 hours, Saturday, Sunday. And you will get some assignments, guys. You have to do assignments. Simply, there's no use of sitting in my class and going. At least every day, remaining day, every day you spend 30 minutes to 60 minutes. Every day you have to spend 30 to 60 minutes, not more than that. Every day, consistently. Every day, 30 to 60 minutes you spend. Listen my topics again, and do the assignments. Do the quiz. I'll give you the small quiz questions on each topic. You do that. That is more than enough. And next about, there's no offline classes, only online, Aditya. No offline classes, only online. And second about LMS, yes, every of my class will be recorded, guys. Now this, whatever I'm telling, also recorded. This also will be available in the LMS, right? So Saturday session, I'll upload in the Sunday morning or Saturday night. And mostly I'll try Saturday session by Saturday night, Sunday session by Sunday night, and content you will get mostly by Monday. PDF only you will get it. You will get the PDF of, so PDF you will get by Monday. Neatly formatted PDF with all the diagrams, all that you will get on Monday. Saturday class video will be uploaded by Saturday night. Sunday class video will be uploaded by Sunday, and Monday you will get the yes, Gopal. Yes, 15 plus years. Yes, you can try now with the senior level. Yeah, immediately after the class, I'll upload the videos, guys. Some days, the video will not be available immediately. Okay, some days video will sometimes Zoom will get a trouble. They may not be available immediately. That time it takes a little bit extra time. Otherwise, after the class, maybe in a 1 to 2 hours, I'll get video ready and I'll upload it. Okay, number one. LMS will be there. LMS only for a 3 years, guys, not lifetime. NMS only for 3 years, no lifetime. but I did not delete any of the LMS till now because, see, for example, there are students who, most of you joined for many of the courses, right? I think most of you, I think 90% of students, I am seeing the names here. You are there in you are there in my AWS, you are there in my DevOps, you are there in my microservices, you are there in my Angular, you are there in my React, you are there in my DSS sessions. Data sections also, you are there. So I didn't delete any of that. Some of you completed 5 years also, but I didn't delete. Practically, I'm telling 3 years. Meanwhile, if you join any of my course, it will be again extended to another 3 years. No worries. Yeah, Santosh. In the next coming 3 years, you enroll for any other new course, again it will be extended to another 3 years. Simple. All courses will be extended like that's what I'm doing from everybody. Okay. So whether I answered all of your questions? Coming to this, 5 months it takes, and previously some of my courses have been delayed. Honestly, I am very sorry that time due to some this that works. Some of the courses are delayed, but this time 500% this course will be completed by 5 months. Number one. Why I'm telling this? Because my next AI/ML, artificial intelligence, machine learning batch also scheduled. So I have to start AML machine learning batch. So for that reason, I have to complete this. Yes, mostly February I'm planning. February, March, February, March. Some of the students are asking to, they have been waiting from last 6 months. So I had to start either Feb 2025 or March, mostly February, March 2025, AML will be launched, right? Yeah, that's what I will complete this on the time. No worry. And no offline sessions, only online, Zoom like this. You sit at your home, I'll be here. And price of this 30,000. And I know all of you are from my old students. And so you pay 25,000, guys. So now you pay 25,000. Oh, wait. You pay 25,000, which is including everything. Okay? 25,000, which is including, yes, 25,000, Abhishek. What is that, Swadhin? I didn't get your point. See, guys, yeah. Even I am also waiting. Actually, I thought to start the AIML in 24 beginning only. Due to some things, I delayed. 2025 is the 2025 Feb or March. I'll be launching first AIML. That is most important because the future, I think you understand. You are not kids. You have 10 plus, 20 plus experience. You know, you understand the importance of AIML. I'm eagerly waiting to how you are waiting to learn. I'm also waiting. Yeah, in AIML, I will tell you, yes, Swadhin, you asked a good question, but advanced question. This question should be asked in 2025, but you asked early. Yes, for AIML course, it has its own system design actually. For AIML has its own system design. Yes, that is also included in that. Right? And you don't feel, guys, 25,000 is more. The content you have seen, I think now, you will not get this whole content anywhere. You go, I'll send this slides as a PDF. I'll send this PDF to you, your email IDs or WhatsApp. I'll ask my team to send it to your email or WhatsApp. You see the content, you will not get anywhere. You try if you want. I don't want to name the top companies which are training. Yes. So 25,000, don't feel that this is high. This is actually less. And system design in future, no self-paced courses for system design. System design will run always the live sessions. Mostly in future, what I will teach? I will teach data structures algorithms. I'll teach live sessions in future, no self-paced. And system design, I'll teach in future live sessions, no self-paced. And AIML, further more time I'll spend only on the AIML courses. All advanced AIML courses about deep learning, neural networks, computer vision, NLP, generative AI. This all I'm going to making a bigger kind of full package, right? Okay, guys, that's about. Yeah, Navneet, you can talk to my team. Okay, guys, 25,000, and that's the final, and you make the payments. So you can, I think tomorrow onwards you can start the payments. There are some students like some students eagerly waiting when to pay, when to pay, when to pay. I told Monday 9th is the, I think I like the number 9 usually, right? So I told 9th is the enrollment starts. Tomorrow enrollments will start. Regular classes will be started from next Saturday, guys. Next Saturday, I think 14th, right? 14th December, Saturday at 6:30 a.m. Regular classes will be started. Okay. Then the last. So you have, I think some of you are in touch with Chaitanya, some of you are in touch with the Sweta, and some of the US students are in touch with the Rupesh. I forgot to include this actually. Some of the students are in touch with the Rupesh. Okay. Some of the US students are in touch with Rupesh. Some of the US and Indian students are in touch with Chaitanya. Some of the US and Indian students are in touch with Sweta. So whoever counseling you, you please contact them for any queries or any enrollment process. Okay. They will send you the payment related scanner or something. You can make the payments to that. Okay, guys. So I think you're seeing this. Uh, Before that, Dinesh, very less sessions only, I think. No problem. Beginning one two modules, I think you can, when you come back, you can recover it because I have AML batch planned. So I don't want to, that's what I told you. My previous batches are delayed, but now no delay, guys. 5 months means 5 months I'll complete. If I need, I'll take an extra hour. Instead of 2.5, 3 hours, I'll ask you every Saturday send extra half an hour time. I'll complete in a 5 months. So you pay me 25,000. Whatever I committed syllabus, more than this, I'll give you in a 5 months of time. AML, Python only, Dinesh. I'll teach Python. AML course starts with Python first. Python also is a part of AML, all Python, then I'll start with machine learning foundation, then we'll go for deep learning, NLP, computer vision. Yeah, you need a little bit mathematics, Aditya, mathematics, little bit maths required and statistics required. I'll teach the maths required, statistics required for a machine learning. That all package we have, will plan it. Okay, guys. Jan 2025, we'll discuss about AML, right? 2025, now end of 2024, we'll start learning with system design. AML takes 9 months plus, Benai. AML takes 9 months plus because we have to do a lot. In AML, we'll do the real-time projects. No, that's what we'll complete, because we'll complete system design quickly. The idea is like this. Okay, this is clear, right? I think you have a Sweta number, Chaitanya number, and Rupesh, the US students, some of the US students are in touch with Rupesh. Please contact them for the enrollments. And there is one slide pending. Let me to show that slide also. Okay, thank you, guys. And about AML, don't worry, guys. I have designed in such a way like this. So system design, system design, we are starting now the schedule, right? December, January, Feb, March, April. Okay. By April, system design will be completed 100%. Okay. Now, if I start in a, for example, if I start the AML course in a March, if I start here, this March and April will be the foundation. Okay. Will be the foundation like Python. Python, not very tough, right? Python, you are Java experts. You are working 15, 20 years Java. So Python learning very easy for you. So we'll do the Python in these 2 months and the maths required, maths, statistics. These all foundational we'll do in the March and April. So April, my system design will complete. Then May onwards, the full-fledged will sit on the actual machine learning related. That's the plan. Yeah, Python is very easy for Java. Java you're done means your complex things you're done. So Python is so easy for you. No, not that much, Ashwant. Simple maths required. Very simple maths. I'll teach the whatever required, I'll teach it. Statistics, whatever required, I'll teach. Whatever basic mathematics you need, I'll teach that. So that's what I told you guys. This system design course will not be delayed because I planned AML ahead. I have to complete by April ending, then actual machine learning will start. So in March we'll start March or Feb will start a batch of AML. The March, April will take the foundation of that, then we'll start. And there we will implement the real world applications. If you want to implement an agent, yes. If you want to implement an application like ChatGPT, yes, you can build it. I will build and show you the live application. And you have a separate system design in that. So if you are building AML applications, what is system design? Nobody is teaching. And see, machine learning, if AML apps, DevOps, you know, right? For enterprise applications using DevOps. I am also including DevOps into the machine learning. It is called as ML apps. So this, if you build a machine learning models, how you build that with the Docker and Kubernetes, how you make a CI/CD pipeline for that. I'm still doing research on that. So that will be added. So the course will be super advanced. AML course I'm designing. We'll meet that shortly, guys. That's about, I think, my side over, guys. You have any questions, please ask. Yes. Yeah, just 2 months, Navneet. 2 months. For March, April, I will take the Python very light daily 1 hour, something like that. Foundation, very less hours. School will spend, not much. Because you have to spend system design also more hours there. All right. Total duration of AML definitely more than 9 months. I can't say exactly more than 9 months, guys. Surely more than 9 months. Because you have to learn it. That anyway, we'll see about AML, guys, in January 2025. If you want, I'll take a demo, something like this. We'll plan for that. Okay. System design. Regular classes will be started from next Saturday, 14th December 2024 at 6:30 a.m. Class will be started. Okay. Then Saket, I will give you the code samples for 2 modules. Yes. Yeah. I forgot to say this. Saket, thanks for remembering this. See, these design patterns I'll give you full, guys. These design patterns I'll give you the code. Okay. These design patterns. Yeah, mostly Jan or Feb. I'm planning Feb. Jan end or Feb first week, Dinesh. We'll plan that. Jan end or Feb first week. Jan end after Sankranti festival, or maybe. See, these creational design patterns. Okay. These design patterns, module 3 in the LLD, I'll give you the code. This code will write. I'll write the code in the Eclipse. Fine. Then these also model, these related also I'll show you. Low level design, we can give the code, guys. This simple, I can give you the code of this. We can write a sample code for this. Fine. Then module 7 also we can write the code for this. I think all of you are Java only, right? Any non-Java guys? Any outside GLC students now in this who don't know Java? If we are all Java guys, then I'll give the Java code for this. I'll tell you the concurrency related code samples also I'll give you, Saket. Or Ram Prasad, Node.js. Okay, you can find out the, I'll recommend you that you find out the corresponding code. But if I write a Java code, you can understand, no, Ram Prasad. Yeah, so I'll give you the code in Java. I think you can understand it. What are the roles required for a system designing? Maybe tech leads can do that. Individual principal engineer, uh, uh, principal engineer, right? Tech lead, or maybe technical architect, solution architect. Any of these roles can get a chance to design applications. Munna, which is the most important design, LLD or HLD? We can't say like that. Munna, both are required. Those are like a two hands. First, you have to finish high level. It has its importance. Low level has its importance. Both has their own advantages. You must do high level design first and then the low level design. Is it useful to infrastructure administrator, Revati? Really, I think no. No, not useful for infrastructure administrator it is. Yes, Swadhin. Yes, it will be. AI batch is extreme. This is different and that is different, guys. Both are different courses. Both are different courses. First, I'll start with HLD. Alok. First, I'll start with HLD. Abhimanyu, data structures knowledge is not required. Data structures knowledge is not required. But see, if you are hitting that product-based companies, startup companies, along with system design, you must master DSA also, actually. System design interview, coding round, coding interview, are two different interviews, guys. Rajiv's question. Yeah, we have a DSA course. Pankaj, contact my team. Rajiv, are you taking this course in both on-prem or cloud or mixed? We will discuss both, Rajiv. We'll discuss both, Rajiv, because if you see in the high-level design, before system trade-offs, system design trade-offs, see cloud native architectures. Here we are talking about a cloud, okay? And this microservices on-premise cloud, two options we have to discuss, and we have to estimate. We have to think about how, if you deploy, how the features you have in the cloud, if in on-premises, how you make it. Yeah, Neha. High-level design is created by architects. Low-level design created by developer. We can't say developer, Neha. Depends. Depends. So this is the course I designed for 5 to 20 years, guys. So maybe if you have a 10 years around, both are useful to you. Low level, if you are a team lead or senior developer, but I think developer range, I don't think so. You will get a requirement to do the low level design, but at least senior team members can do the low level design. But for you, require the high level design also. Already you are in the high level. Already you are in the high level. Yes, you have system design, and it is a kind of revision of the low level design. Yeah, Neha, you are doing at least a low level at 8 years. Now you are, say, Nehal, you know the high low level design, right? So next level, you have 8 years of experience. Next level, you need the high level design. You want to go to top tech companies? Yes, you need a low level design. Sorry, high level design. Yes, Abhishek. Yes, your friend who is the project lead. Yes, for those kind of senior people only. Yes. Yeah, Nehal, you learned this. You started already learning HLD. Yes, then this course definitely will help you to boost your high level design in your current company. That's what I told you. This course is designed for two goals. Goal number one, in the current company, if you have a requirement to do HLD or LLD, this will help you a lot. Second, if you want to change a job, if you want to hit top product based companies, I added many of the things, guys. Design patterns added, solid principles added, and microservice design patterns added, concurrency module added. This is for any guys, architects, senior architects, solution architects, even if you are a solution architect, even if you are a technical architect, even if you are an architect or a project leader, a tech lead, if you want to hit the top companies, this syllabus will help you. Thanks, Prasad. After 14 years, you're seeing me. Yeah, there are some guys, even 15, 16, 17. Rupesh, yes, this is really wonderful course for the guys who are looking for a technical lead roles. That's what, from developer to senior developer to technical lead to architect. This steps you can do with this course. It helps in both the ways. Not only in small companies, guys. I'm telling confidently, you after learning this, you will get a confidence. At least you can go and sit interview. You for interview, system design interview, you can face in the Google or man companies or fan companies or top tech companies. Oh, Madiwala, that HSR JLC. Okay. Munna, you are a principal architect. Yes, yes, Nehal. I know these names, whatever I'm seeing, right? Neha, Munna Lal, Rupesh. Rupesh, there are two Rupesh. Rupesh Singh and Rupesh Bema. I think you both are same batch students of Matikere, I think. You see, Rupesh Bema is there in US now. Swadhin, you are 2008 Matikere batch, 2008. Amit, 2007. Adnesh, Matikere B29. Rupesh Bema. Yeah, Rupesh Bema, Rupesh Singh, you are B23, I think I remembered. Yeah, Munna 2000. Preeti Yadav 2009. Yeah, Preeti, I remembered. Preeti, I remembered you, your brother and your father came for enrollment. You and your brother also joined. Bajrang. Yeah, Bajrang also, you are also same batch. Bajrang and Rupesh. Same batch, 2000. Krishna, you are 2005 when I started. Very good. Nice to meet you guys. Vipin, 2016. Saujanya, 2007. Vishnu, 2010. Pushkar, 2013. Aditya, 2014. Nehal 2019, Saket B12 Matikere, Manish 2012, Ashish 11, Abhishek 20, Shankar 2010, Dinesh 2013. Nagash, you are from Hyderabad branch, right? Yeah, yeah. That time I started Hyderabad branch also. That branch was inaugurated by the cinema hero Sri Hari. I think he was now passed away. Yeah, Hero Sri Hari has inaugurated. I have branch at Hyderabad also. That we closed it later. Yeah, Yashwant, B11, Matigere, Vikas 2013, Girish 2013, HSR, Raju, B27. I think Raju, you are Manish batch, right? Our old faculty Manish is there. Pankaj Silk Board, that is BTM, yeah. Balmiki 2007, Matigere. Amar 2000. Oh, Amar, you are also from Hyderabad branch. Okay, good, good. Ankit 2016, full stack batch 1. Rudranath, B25. Madiwala, Deepak Madiwala first batch. I think Madiwala first core Java delivered by Manish, right? Yeah, Amar, B10, Abhishek, 2010 Matikere. Very, very proud to see you guys back. Raju Prasad from Dharmendra batch, okay. That batch I constructed a shed at BTM, right? Very big shed at BTM for 500 students. 500 students. Yeah. Core Java by that time, yeah, Manish started Core Java. Correct. I used to take advance. Very nice, guys. Very nice and very happy and very proud to see you guys happily working in all the companies and still you're trusting me and attending. Oh, Abhishek has teached for Gopal. Yeah, yeah, Abhishek. I think the Abhishek also in US only recently has connected with me. Who taught Core Java to you? That Abhishek also in US recently has connected to me. Thank you so much, guys. Thank you so much for the love, support, trust you have on me. And thank you very much. If you have any questions, please ask. And very nice to see you. And thank you very much. Thank you all, guys. Thank you. Good night to all.